Hello and welcome back to my YouTube channel. In this video, we are going to talk about Raylib. Raylib is a game creation library. With the help of Raylib, we can create 2D or 3D games. We can use Raylib with different programming languages. In this video, we are going to use Raylib with C. So to get started, we have to first install Raylib in our local system. So there are two ways to install Raylib. Either you install it with Brew or with some other package manager which is available in your operating system. But this will install Raylib in only one version in the whole global system. Now what we want to do is we want to use Raylib, a specific version of Raylib in a specific project. Because let's say you are working on two different projects and one of those project demands that you use Raylib version 4 and one of it demands that you use Raylib version 3. So to use Raylib, a specific Raylib version to a specific project, we have to build Raylib from source. So how to do that is first we come to Raylib's official repository, the GitHub repository. Here we can go to whichever version we want to install. So here I want to install Raylib version 4.0, and in the bottommost part of the page we find the assets. So these assets are for different operating systems. So whichever operating system you are on, you can install and extract the source code of the Raylib. So I've done that in my local system. So after you extract the code, if you see the code, there is a folder called src. So if I go into that src folder, there is a file called makefile. So what is a makefile? Now makefile has all the instructions which we need to compile a C or C++ program. So to run the instructions which are listed in the makefile, we have to install a tool called make. You can just do a simple Google search and you can install make in your system. I already have it in my system, so I'll just run the make command in the same folder where we have the makefile. So once I run the make command, it outputs a file called libraylib.a. We need this file. It is a linking file, and along with it we need a few other files like raylib.h, rlgl.h and raymath.h. So in total we need these 4 files from the Raylib source code. 3 files that comes with the Raylib and 1 file that we have generated using the make command, which ran the make file and outputted the libraylib.a file. So I have already imported these 4 files in my project. I've created a folder called lib. In the lib I have pasted the file that was the output of the make command, and the other 3 files I have put it in a folder called include. So we need these 4 files to start off. Now I'll start writing the code. First I'll create a folder called src where we'll have the main.c file. Main file is the first file that we want the compiler to run, right? So here I'll include the raylib.h file, and then I'll create the main function which will return 0 to the operating system, because we actually don't want to return anything to the operating system. We just want to run our game. So here I'll use a function called init window, which is provided by Raylib. It takes in 3 parameters: width, height and the title. So width and height I'll define it globally because we might want to use it in other parts of our system as well, in other parts of our code. Sorry, window width, not window height. I'll keep it as 600 and also define the window height, let's say 800, and I'll use it in this function. And the title I'll just give Raylib game as title for now. So this is a very small, very simple Raylib program. Now what if I want to run it? We cannot run Raylib with a simple compiler, giving the input and get the input. get the output. So what I'll do is I'll create a make file. So this make file will have the instructions as we saw on the Raylib's official source code. They had a make file which we used to run and which we used to have the lib link file back. So in this make file I'll create a few variables. So like cc, I'll use it for the name of the compiler. Here I'm using clang as the compiler, but you can use any other compilers like gcc or something else. Then I'll have some flags for my compiler. So like -w all. W stands for warning, and I want my compiler to give me all the warnings that are there in my code, and I don't want to suppress those warnings. Then I'm giving -std c99, which means I'm telling the compiler to follow the c99 standards of the C language. Then I'm enabling some flags like O2. O2 just means that it will do second level of efficiency. So our compilers are built in such a way that it will make our code efficient before actually compiling it. So this is just a flag for that. Then I'll have some variables like include and link for linking, let's say L flags. So what include means is wherever the header files in my code are present and I want to include it, I want the compiler to include it, I will give the paths for that. So header files, as the Raylib header files, have put it in the include folder in the lib folder. So I'll give -i lib/include. -i we have to write because the include files the compiler will find with the flag -i. And some header files can also be present in the src folder that I'll create on my own. So I can list that as well with -i src. Then for the L flags, which is the linking files that I want the compiler to know. So I have only one, lib_raylib.a. So first I'll give the path for it. It is present in the lib folder. So for linking files I'll give -l. For includes we give -i. Then I'll give the folder name. After the folder name I want to give the file name. Now to give the linking file names we have to give -small l as the precursor to it. And when we give -l, the compiler will find the files which starts with the name lib. So this file has to start with the name lib, and then I'll give the rest of the name Raylib. Then I'll give some more linking files which are provided by the operating system itself, and that has to be included with the -framework flag. So like core audio or OpenGL, also the IO kit, and lastly we have the core audio, OpenGL, IO kit, and also the Cocoa. So these are some of the linking files that operating system provides us, so that we can show the operating system can show something on the, with the help of the GPU, show something on the screen. So that will be our OpenGL. Core audio will be for the, for audios, if we are using some audios in our game. IO kit is for human interaction of the game. So if I'm pressing some buttons and the game does something on that action, so for that we use this linking file. So that's why we have to include this linking files. And lastly I'll create two more variables, source and output. Source is where my main file is, so I'll give that path src/main.c. and then we have the output. We can give anything. So when the compiler will create the compiled output, it will name it this one. So if you want it in some other directory, you can give that path. And then I'll have a command here. So in the Raylib source code we saw that we just did make and it ran whatever is in the make file. Here if we want to have some special commands, So let's say if I do make all, then only something written in this all should run, then I can add it here. So what I want to do is whenever someone does make all in this project's root directory, what should happen is the compiler should create an output directory. It should compile everything and should create a output file. So for that, I'm going to first call my compiler, which I had in this variable, cc variable. Then I'm going to tell it my source file. Then I'm going to write -o for output. Then I'm going to give it my output file. Then I'm going to use the compiler flags, the cf flags, and then the include files, and lastly the linking files. So if I now do make all, it will run this command, and these variables will be changed with its values. And also I want to have a command called run. What run will do is it will first call the all command so that it creates output file, and then also runs that output file. And also I want to have a clean command. What this clean will do is it will just remove the output file. So let's say if I want to do make clean and make run, so it will first clean the previous output and then run the old command to create a new output, and then will also run that output. So this is the make file. Now let's try to run it. I'll go to my current folder to run it, and so this is where my current code is, and I'll just do make run. So once I do make run, it ran the old command first of my make file, and in the old command it ran all these things. So it is giving some error, unknown argument framework. I think I spelled it wrong. It should be framework. Now if I ran it, it ran successfully. It gave me some warnings because I told it to give me all the warnings, but there was no output, there was no game displayed. Now the reason for that is, if we come into our code, we have just asked the window to be initialized. We are not actually drawing something on the screen. So let's start to do that. So for that, I'll first run a while loop. This while loop will run infinitely till the time we want to run the game. So we only want to close the game when the user asks to close it. So let's say the user clicks on the cross button, or it does Control C. So when the user does that, there will be a function which will be called, the name of the window is window should close. So until this window should close give true, which it will give true once the user asks the window to be closed, we should run our game. So once the game run, what we want is, we want to first begin the drawing. So understand this thing, that once the while loop will run, we are creating each frame in the while loop. So first we are beginning a drawing, and then also we are ending the drawing. So it's like every frame we gets created, and then it gets ended, and on the next while iteration again we draw the next frame of the game. So before this, I'll also set the FPS, set target FPS to 60. So what I'm telling is, run my game in 60 frames per second. So whichever frames I'm creating, run 60 frames in 1 second. So one frame in 1/60th of a second should render. So now in between this beginning and drawing, first I'll clear the background, and I'll add, let's say, sky blue color. And then what I want to do is, let's say if I want to have a ball on the screen, so I'll draw a circle for the ball. I'll draw circle V, which takes in a vector, and the vector I'll give, so it's a 2D vector, so I'll do a vector 2D, and let's create some variables for this. I'll do a float ball exposition, let's say 100f, and a float ball's y position, let's say 200f. So because it is floating point, we have to give 100.f2 and 200.f, and then the radius of the ball, let's say 10. Let's use it now here. So the first argument that it took was the center. It was a vector 2. So I've created a vector 2, and the center is the x and y coordinates, which is the 100 and 200. The second one is the radius. So I have the radius here. So I'll give the radius, and then we have the color. Let's just give white for now. And now run the program. So now we see that we have now a game screen which is initialized with the sky blue background color, and it has a ball now of the radius 10 and the x and y position that I told it to. I'll make the ball a little bit bigger. Yeah, now it looks fine. So let's say now this, if I click something, nothing is happening. This ball is just displaying on the screen. Now let's say with the help of my button clicks, I want something to happen to this ball. So what I want to do is, when this while loop runs, the next iteration of the while loop runs, if there is a button click, and I want to do this before the drawing the circle so that I can have the new position. So initially I had these positions, but now I want new positions based on my keystrokes. So what I'll check is if key is key down. So if I press this some key, and the key, let's say, is the key underscore down. So if I pressed the down arrow, what I want to do is I want to change the position. So if I'm pressing down arrow, the y coordinate of the ball should change, right? So the y coordinate on the top is 0, and on the bottommost part is the height of the screen, right, of the game window. So if we want to push the ball down, we want the y coordinate to be more. So once I do a key down, I want the y position to be more. So initially if it was 200, it should be 210 now, let's say. What I'll do is I'll create one more variable called speed, and I'll keep it 5 for now, and I'll just add it. So now if we run our game, and if I press down, it is going down with the speed of 5. But if I press the up arrow, left arrow, right arrow, nothing is happening. So let's fix that as well. So if I press the up key, I want the ball speed to be decreased, so I'll do minus this time. And if I press the right key, I want now the x coordinate to be pushed to the right. So I'll add the speed now to the x coordinate. Similarly, if I press the left key, I want the ball to go to the left to the negative x now. So I'll subtract the value of the speed. So if I run this, now we can see that we can move this ball around with the up, down, left, right arrows. So this is how we can build a small interaction with the game. We can do some more stuff with it as well. Let's say there is a we have played the snake game, right? So this is a snake, and whenever it takes something, let's say its height or its length gets increased, and we can award points to the user. So something like this we can build. I'll do one more thing with it, is that when it is going out of bounds, it is not stopping and it is just going. I'll I'll just have a logic for that as well. So whenever we are pressing the down button, we don't want it to go beyond the bottommost part of the game window. So but the y coordinate of the ball should remain a little bit higher from the bottommost part, because the radius is also there. So we don't want the ball to go down, but the coordinates, the ball x and ball y, is the center of the ball. So the y coordinate should be a little bit higher than the bottommost part of the window, because we have the radius as well. So what I'll check is if someone is pressing the key down and the y coordinate of the ball and its radius, if I add radius to it, should not be greater than or equal to the window height. Should not be greater than equal to means it should be less than window height. So we'll just test it. So if I go down, it is now not going out of bounds if I'm pressing the down button. Similarly, we'll do this with the up as well. Now the y coordinate of the ball should not touch the y coordinate, not the y coordinate. The uppermost part of the ball should not touch the uppermost part of the game window. But the y coordinate is still a little bit down than the uppermost part of the ball, because there is this radius upwards. So what we want is, if I subtract the radius from the y coordinate of the ball, it should not be less than 0, because if it is less than 0, it means the ball has gone above our screen. So it should not be less than 0, it means it should always be greater than or equal to 0. Let's test this as well. So now it is not going beyond the limits, even if I'm pressing the up arrow. Similarly, we can do this for key right and key left. Now for left, I want if the pole x minus radius should always be greater than 0. Similar thing, but now it's instead of ball y, it's ball x. Sorry, this should be our ball x. Key left, sorry. And key right, the ball x plus the radius should not exceed, means it should be less than the window width. So now if we see, the ball does not go out of the bounds. So like this we can build simple physics of the game. We can of course enhance it. We can build the Flappy Bird game with it, or the snake game with it, where we have one more rectangular thing here, and whenever our ball touches that, our length of our ball increases. So yeah, this was just a demo tutorial for how to initialize Raylib and how to use C with Raylib. In the upcoming videos, we'll see how to create a little bit more advanced games with this. So hope it was helpful. Thank you.